Welcome back, everyone. So today we will continue chapter number two of networking course, and we're going to discuss the second part of chapter number two. In the first part, we discussed networking components, like we discussed repeater, we discussed why do we use repeater, we have discussed hubs, and we have also discussed the different types of hub, active, passive. We have also discussed what are the switches and different types of switches. And today we're going to discuss some more networking components. So these are the three things which we will be talking about in this video. We will discuss router, network interface card, and wireless access point. We will discuss a couple of specification, types of network interface card, etc., etc. So let's get started with the router. So a router, very, very important component, very, very important device. So router is typically used if, we can say we are connected with the rest of the world through the router. For example, if you connect, let's say this is you. You are, for example, located in Lawrenceville. And if you visit a website, and that particular website, let's say this particular web server is located maybe in Germany. So how do you see this website or visit the web server? By using router. So router connects us with the rest of the world, and all international and even the long distance national calls are get done, or we use the router in order to get them done. Okay. So router, first of all, these are some of the key points. I put them right here just for the reference. You can note it down. Router is a layer 3 device. As you know, the layer 3 mean router runs on network layer. So please recall your OSI model. It runs on the network layer. And when a data gets to network layer, so what we do is we basically add IP addresses. So the router is the device which runs, if you remember, the layer, network layer, router is right here. It appends the IP address of source plus destination and make the data a packet. And then that data can become a frame, of course, if when it gets to data link layer. So what happens? It runs on the layer 3. So source and destination IP addresses are added onto the data. It becomes a packet. WAN device mean it connects two or more local area networks, two or more networks. So if you want to connect the networks, we use routers, because switches are used to connect devices within the network. Okay, so router is basically a WAN device, unlike the switch, which is a LAN device or other. Router is basically internetworking device. Why we call it internetworking device? It is not a networking device. So switch is basically a networking device, while router is internetworking device. Why? Because it connect to or more local area networks, like different networks can be connected by using a router. We're going to talk about it in detail. Then we will discuss its own broadcast domain. I'll come to these key points again when I'll give you the overview of the router. So let's get started with the router. Okay. First of all, sorry about that. First of all, the router. Router is basically an internetworking device, while switch is a networking device. So what is the major difference? The major difference is networking device connects devices or computers within the local area network. Within local area network. For example, switches, for example, hubs. Switch and the hub. While internetworking device, what it does, it connects two or more local area networks. So two or more local area networks, if you want to connect them, we need an internetworking device, and that particular device is the router. For example, maybe your home network with your ISP, we need a router. Okay. So if you want to visualize this, okay. So visualization is like, for example, this is, let's say, your local area network, let's say the campus building or something. We got one server down here and plenty of devices connected with it. Let's say this is a switch. Let's make it a switch, and we got multiple computers connected with it. Okay, so we have a networking device, and networking device connects the devices within the local area network. Now, if you want to connect two local area networks or more local area networks, let's say this is the LAN 1, local area network 1, This is, for example, LAN 2, local area network 2. I mean, let's say the network ID of this LAN is 10.0.0.2, for example, and let's say this is 192.168.1.0. So these are totally entirely different networks. If you want to connect these two networks, we need an internetworking device, and that is the router. And right here, if you guys see here, the network ID, the network ID is, let's say, 10.0.0.1, for example. So these computers can be 10.0.0.3, for example, 0.4, 10 dot, for example, 0.0.5, for example. For example, I'm just giving you an example. So they should belong to the same network ID. We will discuss the IP addresses in detail. We have a complete chapter on IP addresses, chapter number 4. We will be talking about all IP addresses. Okay, then you will have the better understanding about subnetting and IP addresses. Right here, if you see, I mean, in this local area network, we can have different computers having 10.0.0.1, 10.0.0.4, and so. So this entirely different network can be connected with the entirely different network by using a router. But in the switch or networking devices, we connect the devices using the same network ID. So simply you can say the network devices, in the network device, it allows only single, or you can say same network ID. So it means it forms or it connects the devices within this single local area network. While here we can actually connect the routers or internetworking devices, connect or establish communication between, or establish communication or connects or establish communication between two different networks. And that's basically the requirement of the router as well. Like, for example, let's say on these two ports, let's say when you connect the two local area networks with the router, so on these ports, there should be different networks. If you connect, for example, the same network, let's say if you have this network, and let's say on the other side, if you connect 10.0.0.3, for example, another LAN. So now you know what will happen? You cannot connect such two local area network because these are the same network. Your router will get confused. So it has to be a different network on the other side. Then the router is going to actually connect the two networks. Okay. So let me just give you some more example about it so you can have a better understanding on the networking device. So for example, I have two devices. Let's say I have a computer. Let's say I have this computer and let's say another computer. And this computer IP address is, let's say for this computer is 10.0.2.2, and this computer is 10.1.1.1. So I want to connect these two devices with each other. How could I connect that? Do I need a router or do I need a switch, for example? So I need to decide. I want to connect these two computers. Maybe they can be distant apart. If you want to connect them, so we will look their network ID. So these are the subnets of class A, and the class A IP address would be 10.0.0. This is basically the network ID. This is called the network ID through which the local area network can be identified. So you guys can see here, that's the network ID and these are the subnets. Subnet mean, like, for example, you can vary this IP address and you can create different IP addresses. This is called subnetting. We will discuss the subnetting in detail in our coming chapter. Now, what's going to happen if you want to connect them together? We'll see that network ID is same. They will form the same local area network. So the device which can connect them is switch. So now we can actually put the Ethernet cable back to the switch port of this one for this one. And again, these two devices can communicate. Now, for example, if I change the scenario, now I got another PC, let's say this computer, one, and that is another computer, okay? And these two computers, let's say this computer is on 10.0.2.2, but this time this computer is 11.0.0.1. So can I connect them with the switch or the router? What do you think? What would be the device which we can use? So in order to connect these two devices, maybe they are distant apart, or maybe they are close, maybe, but connected with a different network. So if that's the scenario, if you want to connect them together, again, please remember one thing very important. this particular device is connected with a different LAN now. Why? Because network ID is different. And this is connected with a different LAN because network ID is different. So if you want to get them connected, so they can be only connected by using our internetworking device, and that is router. Why? Because network ID of this computer LAN is 10.0.0.0, and network ID of this with which this computer is connected, it is 11.0.0.0. This is the network ID, an ID or network ID. So they can only be connected if you, for example, provide a different, if you use a router. They cannot be connected with a switch. Okay, so bottom line is, so in order to connect, or for example, we need a router to connect to different networks, having different IDs, having different, or running on a different domain, you can say different NID, network IDs. Okay, this is just a simple idea. Or for example, this is the answer for internetworking device. Why routers are internetworking device? Because they connect to different local area networks. So internets, okay, two devices would be connected with that. Now let me just give you another example, a detailed example, which is going to give you the brief understanding about the routers and the application of routers. So for example, let's say this will give you the better understanding about it. So for example, this is my local area network 1. This is the LAN 1. And this is, for example, LAN 2. Assume that this is, for example, GGC network. And that's, for example, Kennesaw, for example, KSU. Okay. So in the local area network, as now we agreed on one thing, if you want to connect the computers within the local area network, so what do we need? We need a switch. To connect two different networks like KSU and the GGC, we need, for example, a router, and that's what we have. Now, for example, the GGC network ID is, let's say over network ID here is, for example, let's say 10.0.0.0. This is the network ID of GGC. And let's say the network ID of KSU is, assume that, let's say 192.168.2.0, for example. So this is class C IP address. We will discuss in detail, so don't confuse it right now. For now, just try to understand, like, this is the IP address of computers, like unique identifier over the internet. And this is the class A IP address. We will discuss that, the difference between all these IP addresses A, B, and C. Now, for example, these this computer IP address is 10.0.0.1. This is 10.0.0.2. This is 10.0.0.3, 10.0.0. For example, 4. And let's come to here, come to KSU. This computer might be 192.168.1.1. 2.1, sorry, 198.168.2.2. This might be, for example, .3. I mean, remaining 3 octets would be same. .4 maybe. Now, as I told you guys, these are two different networks. So what we're gonna do is we will connect these two switches with a router. It will go on this particular port, and this will be connected with this port. Very, very important. Computers cannot directly, we cannot connect the computer directly to the router. So routers are connected through switch. So please write it down. Let me write it down this point for you. So we cannot connect computers or PCs directly to routers. So PCs cannot directly to be connected. So routers are connected through switches. Connected through switches. So we use switches in order to connect two networks. Of course, two switches, then we connect them with these ports of the router. Typically, router got 2, 4, 8, 16, 32 ports. Router doesn't have that many ports as compared to switch. Switches always got more ports. Now, what is gonna happen here? Now, if you guys see here, if any packet, let's say if this particular computer wants to send a packet to this computer, so this packet from the switch will go to the router. Now router maintains this routing table, and on the router, what is in the routing table? This is called routing table. Router will see on the port number one. Let's say this is port number one, and that's, let's say, port two. On port number one, what is the network ID? 192.168.168.12.0, and here we got 10.0.0.0. So whenever any packet arrive on port 1, router will see it comes from this network ID and see the destination. Let's say source is this 192 dot something and destination is 10.0.0.3. So router will see from where to where this packet is heading to. So router will take the packet from here, forward it to the next port, and then the switch will open it up, see the MAC addresses and all. So router will just check the IP addresses. Router will just check the IP address of the packet. Got it? Which IP address, source and destination. And based on source and destination, like say destination is 10.0.0.3. So router will see what is the network ID. Network ID is 10.0.0 connected with port number 2, forwarded to port number 2. When this packet will be forwarded to port 2, then this packet will go to switch. Now switch will open the packet further, find the MAC address. And as we already know that switch will forward the packet to only to this particular address. If there would be hubs, if we use hubs instead, so what's going to happen? It would be broadcast to all the computers. So this is basically what happens. Okay. So please remember, router routes the packets. It basically tells, it's just like a map. It basically got just like a Google map. It just tells how the packet would be transported. So this is basically what router does. Okay, and I think we have covered a couple of things here. Let me just go back to key points so everybody is clear. Layer 3, IP addresses, source and destination. WAN, connect 2 or more networks. Internet working device, connect 2 or more local area networks. So it is very important because router has few domains, few ports. Always it has less ports as compared to switch. Switch got more ports. It has few ports. All the ports are broadcast domain. Broadcast domain mean they got different, they can actually propagate. Let's say there are 2 main packets. So if 2 main ports, for example. So each port has a capability to broadcast the packets. Why I'm calling packet? Because it just have IP address, router doesn't know the MAC addresses. So it can broadcast. Each port has a capability to do broadcast, to do unicast, to do multicast. It is basically what routers got the capability of. So router can unicast to specific switch because routers are connected with switches. So routers are basically connected to switches. Okay, so routers, there could be, for example, this is router, can be connected with multiple switch, S1, S2, S3, S4, 1, 2, 3, 4, 5. So router can basically propagate, broadcast to all switches or only send to a specific switch as well. Okay, that's basically the difference. So we talked about IP addressing. It maintains the routing table, tells how the packet can be transported, and these are some port numbers. I'm going to show you another scenario to give you more deep understanding. Let's say, for example, this is a scenario. So assume that these are different local area network. So let's say I have a computer A. This computer wants to send, computer A wants to send a data to computer E. So wants to send the data to E. Based on the routing table, doesn't only contain the ports information, but again the whole map. So now there can be multiple paths. You guys can see the packet can go from firstly this router, then this router, then this router, and then go to A. There is another path. The other path could be go to this route, this path, then it can go to this computer, then go to this path, then go to this path, then go to this path, and then go to E. So there are plenty of paths, diversity right down here. So all these routes are basically stored in routing table. So what happens typically, let's say this is a computer, if you want to see a scenario, and let's say this is another computer on another local area network. Let's say this is 10.0.0.2. This is, for example, 11.1.1.1, for example. So this is connected through a router. Okay. And let's say this is router. Again, as you know, these are switches. Let's say this is another switch, that's another switch. So first of all, what's going to happen? This computer wants to send the data to this computer. Now, firstly, what's going to happen? It will forward this to switch. The switch will have a packet, like complete packet. like something like that will be happen. So in this, when the data will get to that, it will have source plus destination IP addresses, okay, and the MAC address. IP address, source MAC address, IP is 10.0.0.2, and destination is 11.1.1.1. Then it does have the source MAC address, source M, and destination MAC address as well, because switch is on the data link layer. So MAC address, let's say this is A and this is B. So that's A MAC address, that's B, for example. Now when the packet will get to that, switch will see that this computer is not in located here. Like switch will see that this computer is not in my domain. It will forward it to router. Now router will open up and router will see what is the destination. Router will see, because there are only two ports of the router. Router will see, okay, the packet came from here and destination is 11.1.1.1. So let's say this domain is 11.0.0.0. So it will say, okay, I need to replicate the packet on this direction. So router will forward it to this switch. Now when the packet will get to this switch, packet again, the switch will see the destination MAC address. Like this is B, because again it will have the frame when it gets to this, and it will be forwarded to the specific computer only. So this is basically end-to-end communication when you involve a router. Okay. And one thing which is very important. So if you see a router and switch, routers and switches both basically look same. So both look same. How you can differentiate it? Switch will have more ports. There would be a lot of ports if you see a Ethernet switch, and router will have few ports. Technically speaking, 2, 4, 8, 16, even 32 as well. But switches are 48, 64, even 128. You will see plenty of ports. So you'll see, if you see more ports, it means that particular device is basically a switch. Okay. All right. One more thing, which is people, they confuse gateway with a router and they feel like gateway and router both are same thing. That's not true. Gateway typically it operates on application layer. It basically operates on application layer, like the topmost layer, and it is basically entry and exit point of the network, okay. And it can be a separate device. You can have a separate hardware or a software separate device which can control the traffic, like letting the traffic in and letting the traffic out, like just like a firewall. Okay, you can assign the gateway as a firewall, or you can basically configure gateway. That's most of the case. We configure the gateway onto the routers. So routers can be typically used in order to configure the gateway. That's why people, they think routers are basically on the routers are the gateway, but because it's just a configuration. So this is the routers. I think we have talked everything we have covered about the routers. This is basically the fast Ethernet ports, like for example, where you connect the switches. Okay, and these are the different availability, like with the speed of 10 Mbps, 100 Mbps, 1 Gbps. Even nowadays, it is 500 Gbps routers are available. Like for example, the data which travel through the router, like coming through the switch and getting to forwarding to the other switch, it can ranges up to 500 Gbps as well. So these sort of routers are available nowadays. So that's it about the routers, and let's move on to the second component, and which is the network interface card. So let's move on to network interface card. So first of all, the network interface card, NIC, this is basically a circuit. Like it's basically a card, like a physical card circuit, which typically we plug it in onto motherboard. I'm just talking about the Ethernet based. There are the wireless network interface cards are more common nowadays. So it is basically plugged onto motherboard. It's a physical card. In fact, it is a physical card. It is basically a circuit. It's basically a circuit board, like maybe you guys have seen the RAM and all that. It's like that. But on the other side, when you, let's say this is your motherboard, when you plugged it in, on this side there would be Ethernet port, and on that particular port we can plug in the Ethernet cable having RJ4 connector. Maybe you guys have seen those Ethernet ports. So basically on the in the internal side it got in network interface card. As name suggests, interface card. So network interface card provides interface between computer and the network. Computer and the network. What does it mean? It means if a computer wants to send an information, let's say this is a computer and that's for example your network. Okay, locally network switch and all that. So if a computer wants to send any packet, this is switch and any packet or any information over the network, it needs a network interface card. So network interface card basically forwards the packet. So it's not the computer. Within the computer, this is network interface card which forwards the information. So that's your computer. In your computer, you got network interface card. It forwards your data over the network. So that's why we call it, it's basically an interface. Other than that, it also provides an identity to your computer. Provides an identity to the computers. And how they provide the identity, it's basically the MAC address. MAC address, I'm gonna give a detail about this MAC address in a bit. So network interface card, it got a MAC address, medium access control address. Okay, this address, which typically we call the computer MAC address, which is basically the switch, right? Remember, the switch understand the MAC address. So that's the MAC address of the network interface card, in fact. So what happens if you guys see down here, this is your computer. If you want your computer to get connected with internet, with other devices, we will install this NIC. And this NIC on the other end, it will have the Ethernet port, which will go all the way to switch. And then it will be connected with the other Ethernet port. Like if anybody wants to get connected to the network, they need to have a network interface card, and those network interface cards should be connected with the switch using Ethernet cables. Okay, and then information travels over the network medium by using that. Few things that you need to know about network interface card, because network interface card, first of all, the network interface card is also called LAN adapter. It's also called LAN adapters, or it's also called the network adapter as well. The short form is network adapter, network interface controller. Interface controller. It's also called network interface controllers. Now, if any device, for example, even printers or whatever, so any device, and this device can be a computer, and that device can be, for example, a printer, anything, printers, for example, thermostat. Any device who wants to connect to a network, it needs network interface card. Okay. And now this network interface card has a unique 48-bit unique serial number, and that serial number is stored onto the ROM of the NIC. So NIC got a ROM as well, okay, and it cannot be changed. So this is, for example, let's say this is over 48-bit network MAC address. Let's say this is over MAC address of NIC, and this is something like, for example, let's say 48-bit. And let's say it is 34, for example, let's say 54 AF, let's say FF, let's say EF01, for example. So this is something how your MAC address looks like typically. If you see right here, this is basically 24 bits, and that's 24 bits. So total it becomes the 48-bit. This is a hexadecimal representation. Hexadecimal. Now within this 48 bits, there are mainly two parts of MAC address. Okay. So first 48 bits are basically assigned by IANA. IANA is the International Assigned Number Authority. So, and other 24 bits are basically assigned by vendor. So vendor has assigned it, like the product number or something. That's basically one. And this IANA has assigned, it's called OUI. These are fixed. OUI is basically, it stands for organization unique identifier. Unique identifier. And this is the vendor specific example. So vendor has specifically assigned it. So this is, for example, something like 3454 AF FF, let's say EF01. So this particular area is OUI assigned by IANA. Vendor cannot change it. And this is basically the vendor specific, like for example, the serial number or something like that. If, for example, you see multiple the networking interface card, NIC, if you got multiple NIC, if you have multiple NIC, it means you got multiple interface cards and multiple MAC addresses. You will see the multiple MAC addresses. In fact, for each MAC address is for a different network interface card. Typically, the internet speed, let's say, let me give you another idea. So for example, let's say we have over network, this is the network interface card. And let's say this is my network interface card transmission speed, because this is from where the data will go out. Let's say the transmission speed of my network interface card is 100 Mbps, for example. Now, what does it mean? It means maximum 100 million bits can be transmitted, can go out, or can get into your through your network interface card. If your internet connection, if you buy the internet connection of, let's say, 300 Mbps, still it's not going to improve your data rate unless you change your network interface card. Because even the network speed is 300 Mbps, but your NIC is capable of taking only 100 Mbps. So you need to change your network interface card if you want a high speed internet. So this is just a basic overview of network interface card, NIC, what exactly it does. Now let's understand the working of NIC, which is very, very important. So first of all, network interface card, it works on two layers. It works on physical layer, like the lowest layer, the first layer, and it also works with the DLL, data link layer. Data link layer. Why for physical layer? Because it forwards the packet in the form of signal. So it forwards the packets. Frames, in fact, not the packet, I must say, use this word. So it basically forwards the frames to network. And it also, it adds the MAC addresses. Just switches, they use it. So it just basically it adds the MAC address to the frame as well. To make a packet into a frame, we need a network interface card. So let's try to understand the working end-to-end communication of network interface card. Let's see the sending operation. So for example, this is my computer, and I want to send the packet, a frame, to my receiver, to a network for example, over the network. So first of all, what's going to happen? We will get the data or the packet from network protocol. From network protocol, we got a packet. Now that particular packet will have this information, because that's a packet. So it will have the source IP address, it will have destination IP address, and then it will have a data as well. So this particular thing is called a packet, which we will get from network protocol. Okay, like for example, I will get it from, let's say, from the router. Source IP, like this IP address, sender's IP address, and the receiver's IP address. When this particular packet will get to network interface card. Now this packet will go to network interface card. This is, for example, your NIC. Now what's going to happen in the NIC? NIC, or the network interface card, will append two main things: source MAC address, destination MAC address. Okay, by using the switch, destination MAC address, source MAC address. Again, source IP address will remain there, destination IP address will remain there, data will remain there, and beside that, it will also add a CRC. CRC is basically for checking the error checking. Like if there is some error occurs during when the packet got to the network interface card, because after NIC, the packet is going to leave. So now this particular is called frame. Why we call it frame? Because we have added the source and destination MAC address here. Okay, when you add it, so this is called frame header. As you know, if you add something before the IP address, that's the header. And this is CRC, cyclic redundancy check, error check. So this is called trailer of the frame. Now this is something which NIC will convert into 010101 and all that, and it's going to forward it to network medium. Okay, so if I just want to, if you want the points for here, so the first thing is what's going to happen. NIC receives the packet. NIC receive the packet from protocol, and these protocols typically run on a router. Number two, after receiving that, it will add headers, header and trailer. What is header and trailer? Header is basically over where we have the source and destination MAC address, source plus destination MAC addresses, and trailer will basically add error checksum. Like for example, there should not be error because the data is going to leave. And then the third step is convert this frame into binary, or you can say signaling. Basically, it will add the signaling. Okay. So this is basically what happens when the packet get to network interface card. I believe this will clarify a lot of things. What is the role of NIC? Let's see what happens on the receiver end. Let's say, for example, when, for example, we receive a packet from network. So let's say we receive a packet from network, and the packet is, let's say, in the form of 010101, something like that. So we have received this packet from the network. So from the network, we receive the packet. This particular packet will directly received by network interface card, NIC. And NIC will, when receive it, it will convert this packet into, again, a frame. It will form a frame. And what would be in the frame? Source MAC address, from where the packet came from, destination MAC address, source IP address, the same thing again, destination IP address. Then it will have a data. Then it will have the error checksum. Like it will check whether error was occurred or not. There was error or not, error checking or verification. Like for example, we receive a packet from network. There might be some errors. So it will be checked down here. So simply you can say what it does, it converts binary or bytes, binary to frame again, having MAC addresses and all. Then what the next thing is, it's gonna verify the MAC address, like whether it is for me or not, MAC address, plus it will also verify or checks for error, like error detection and correction. Further, what it's gonna do is, because it's gonna actually forward a packet to network protocol, like it will have source IP, destination IP, and just the data. So these things, like this checksum, it will be removed, and this thing will be removed. So it will remove header and trailer, header and trailer, and forward packet to protocol. And then from protocol, it will be forwarded. When this packet will go further, source and destination IP will be removed, and then it will go to data, and data will present to application, and user will see this application. Okay. Those things would be removed. Few more things, like last few things that you need to know about network interface card before I jump into wireless network interface card. There are one or two more things that I need to tell you guys, and let me just wipe this thing here, clean this, and tell you guys. Okay. First of all, there are different modes in the router, in the network interface card. By default, there is a mode on your network interface card, which is called promiscuous mode. So promiscuous mode. What is basically a promiscuous mode? Let's say this is your network interface card. By default, your network interface card has applied a promiscuous mode. Promiscuous code, let's say it has a MAC address, A MAC address is, for example, AAA. So for example, if it is a wireless network interface card, for example, like kind of an antenna, it will basically sniff every traffic which is going through the network. Let's say if you use a Wireshark, in the lab we're going to use Wireshark. If you turn on if the promiscuous mode is on, it's basically receive every packet. Let's say you have a hub here in the network, so it will receive, because hub broadcast the packets. So by using promiscuous mode, your network interface card will receive all the packet. Let's say if the packet is for BBB, it will receive it. CCC, it will receive it, even though its MAC address is AAA. If you turn off the promiscuous mode, then only it will receive packets meant for AAA, which is over MAC address. If you turn off promiscuous mode, so if you turn off promiscuous mode, it's going to receive only packet meant for it and discard the other packets. But if you turn on the promiscuous mode, if you turn on this promiscuous mode, it's going to sniff every traffic, every packet. But again, having said that, if you have a hub deployed onto the network, then of course you can sniff the others packets as well. So and again, if for example in the network interface card, if for example you want to do the broadcasting, you want to send data to everyone, for example, then the MAC address is typically, we use a MAC address. Like for example, if the packet, let's say if you go down here, if you want to broadcast, then source and destination MAC address is 111. Like we use FFF for source and destination if you want to broadcast. If you specifically want to send to a computer, we will use the specific address. So two things that we're gonna put it down here. Let me just add a new page here. Let's see how can I add it. Oh, all right, it's gonna actually go to next page. Okay, so let me just clean this and let me write it down there. So for example, let's say if you have a frame, let's say if we have a frame, and let's say that frame means it has source plus destination IP plus source and destination MAC address. If we have a frame and in the source and destination MAC address is F, like it means all ones. It means the frame is basically a broadcast frame. So network interface card is gonna basically broadcast that particular frame. But for example, within the frame, if the source and destination IP address are properly defined, then it's going to be unicast frame. Okay, so these are the two different types of frame that you will see. So I believe we have covered everything. And again, in order to run or make the network interface card enable, we typically use NIC drivers. When you install a network interface card, most of the operating system, they pick up the driver, and network interface card start broadcasting the signal or start receiving the signals. Okay. So that's it about network interface card. So we have discussed everything that you need to know about network interface card. We have discussed it's basically a physical card installed onto the motherboard, provide the interface between computer and network. If a computer wants to get connected onto the network, it needs a network interface card. Okay, it has 48 bits. We talked about it. And then we have also discussed the sending operation, like what happens when the packet arrives to network interface card, which means it got to physical layer and data link layer, DLL and physical layer. What happens? We basically make a frame and forward it. So let's move on to our last point here, which is the wireless network interface card, wireless NIC network interface card. So wireless network interface cards are exactly the same as of network interface card, but the only difference is that there is no wires, there's an antenna, and they broadcast the signal by using different technology. Like typically they use Wi-Fi. They are configured with Wi-Fi, and the Wi-Fi standard is IEEE 802.11. That's basically the project of IEEE, and they basically designed this wireless fidelity wireless transmission of RF signals. So all you have to do is you just have to connect your network interface card, connect to the network using SSID, which is the name of your router, name of your network interface card. It stands for Service Set Identifier. It is exactly the same as of the Ethernet one. Like, of course, it can broadcast, unicast, and all that. But again, the thing is, this it doesn't require, no wires are required, no wires. So it transmit the signal by using Wi-Fi, by using different technologies of Wi-Fi. If you guys have seen AC, like something like 802.11 AC or something, it means this denote just the standards of the Wi-Fi. Okay. So let's move on to the last agenda item for today, and that's the wireless access point. It's going to be a very short one. So wireless access points. So wireless access points are basically the devices, like the boxes that you guys see at your home. So typically this wireless access point is very close to a hub. Like it just like a hub or just like a switch. Can be a switch as well. Okay, it can be integrated with a switch, but without wires. Without wires. And it mainly combines, like if this is your access point, mainly this access point will have two things: a switch or a hub to connect the devices, plus it does have the router as well. So this switch, what it does, connects devices within local area network using same network ID, right? The one which is assigned to your local area network, assigned to your local area network. While the router, what it does, it connects your LAN or your local area network to ISP. Okay, so that particular box basically combines both of the things. One thing which is very important here, here there is an acknowledgement system as well. So the difference between hub and access point is, the major difference is acknowledgement system. Acknowledgement system mean when sending station or sender sends a packet or a frame, then receiver must acknowledges it. It just acknowledges that I have received the packet. Other than that, it do one more thing to avoid the collision. Like for example, if you got a single, let's say for example, if we have a single collision domain, like one door, remember the same example, then how they can avoid it, sender, each time sender, let's say this is a computer, wants to send the data, sender must send an RTS, request to send. So request to send mean like it will see if the domain is free or not. So what's going to happen next? It will be received by CTS, clear to send. So clear to send, like a handshake. So there would be a handshake each time whenever sender wants to send something. So it will RTS plus the CTS. Once it received it, it can start sending the packets, sending the data. Okay. One thing which is very important about wireless access point, and that's basically, let's say you got an access point, and let's say if the data rate of your access point, let's say you got 54 Mbps data rate. For example, 54 Mbps, it's a standardized data rate. And you got 10 devices connected with that. So then each device, let's say this is access point, the data rate which you are getting is 54 Mbps. And you got 10 devices connected, 1 and 10. So then each device will get 5.4 Mbps data rate. It would be splitted around all these. If, for example, because bandwidth is being shared. So that's it about over chapter number 2, part 2. If you will have any question, please do let me know in the class. We will see you guys in